Okay, Kasif, let's start our topic now. Okay.
Yes.
So as per our discussion, we are going to start our first topic. You can say basic configuration, you can say, or initial configuration.
Right.
Okay. Okay, so what is a firewall? First, we can start discussion on Cisco ASA, but what is firewall? Firewall, what do you think about the firewall? Kashif, anything?
Yeah, in general, like it denies anything by default until we allow anything explicitly.
It's deny anything by default, right?
Yeah.
But Kashif, it's depend upon vendor.
Okay.
Depend upon
Right.
vendor. Okay. So what is firewall exactly? Firewall is just like a router. Remember always. It's just like a router. For
Okay.
example, you can configure routing on router, right? NAT on router, VPN on router. So
Right.
these features, these options you can configure on router, but same thing you can configure on firewall.
Right.
So firewall is just like a router, but we
Okay.
have some advanced feature option in firewall, which router cannot provide you.
Okay.
So firewall is a system, you can say, or group of system that manage access between network. What is between network? For example, in firewall, we can discuss this term is called inside network. Okay.
Okay.
Or you can say trusted network, inside network.
Okay.
Or you can say we have LAN zone and WAN zone and DMZ network. What is DMZ network? Any idea, Kashif?
Yeah, it's like a demilitarized zone. So it's a kind of like the zone between, for example, outside world and inside world. So anyone coming from outside has to come through DMZ before he enters into our internal network.
No, he is not allowed to access internet. Outside person is not allowed to access LAN. DMZ we are using, Kashif, DMZ we are using, for example, if we have web server, okay, or DNS server, or FTP server, or SMTP server.
Right.
So these servers I want to allow to my outside user,
Right.
Because see, if I'm trying to allow anyone from the outside to access my LAN,
right.
So the traffic is coming from untrusted network.
Right.
Traffic is coming from untrusted network. So it may be possible this outside user, he can compromise my other devices in my LAN.
Right.
And in my LAN, I have some confidential server, my company confidential servers.
Right.
So that's why we can create a demilitarized zone. Here we can put our servers, and these servers I want to allow for my outside user.
Right.
So whenever they will hit, for example, if this outside user will hit onto this WAN interface. So as per my configuration on firewall, my firewall will redirect this traffic onto the DMZ side.
Right. Correct.
And see, we can do a lab because this is called destination net translation.
Right.
I can show you with practical how to redirect our traffic.
Right.
So we have LAN zone. It's called trusted network. WAN zone is called untrusted network, and we have DMZ, demilitarized. Clear now, Kashif?
Right. Yeah.
Okay.
Actually, just to, I'm from industrial control system background, so generally, like it's bit different than IT.
Okay.
So when I was telling from outside to inside, because generally it's needed. So for example, like remote access.
Yes,
we have to allow. Yeah. And second example, like for patch management, especially, what happens like when it comes to industrial control system, we normally get qualified or tested security updates from the vendors. So what I mean by vendor, like there are big names, Honeywell, Emerson, ABB, Siemens. So just to give some idea, because there is some variation, like when it comes to industrial environments and IT environments. So again, the concept is same. Yeah.
Okay. Yes. Okay. So now we can discuss firewall techniques. Okay. And these techniques are common, Kashif.
Okay.
For example, first technique is called packet filtering. Do you know about packet filtering? Packet filtering.
I have heard about it, but I don't remember,
okay,
to be
no
very
problem.
honest.
See, it's an ACL, access control list.
Okay.
In Cisco router, you can implement ACL, access control list.
Okay.
ACL is what? ACL is a packet filtering firewall. So with ACL, you can filter your packet based on source, destination, services, protocol. So it's a common topic. Packet filtering is a common topic for any firewall device.
Okay. So when we say packet, so what this like means in the background, because what happens, I normally forget this definition. I know the concept, like which you are telling now, like source, destination, protocol, and port number. So that's called packet filtering, right?
Yes, yes.
Okay.
And see, how to implement ACL, we can discuss in our Cisco ACL firewall training. No problem.
Sure.
And if you want to revise your CCNA ACL, so I can revise.
No issues.
So now, what we have, it's a common topic. Packet filtering is a common topic for any firewall device. Like, in Cisco, you can say ACL. In Palo Alto, you can say security policy. In Fortinet, you can say firewall policy. In Cisco firepower threat defense, you can say access policy. So they all are the same, but in every vendor we have some different features, different options. But concept is same. We can filter our traffic based on source, destination, service, and protocol. Clear?
Right.
Second technique or second feature, you can say it's called stateful firewall feature, or you can say stateful inspection. So every firewall is using stateful firewall technique. What is stateful firewall technique? Let's start our discussion. Right. The topology. So we have a Cisco ASA firewall, for example. Okay, this is what Cisco ASA.
Right.
Remember, always Cisco ASA firewall always work with a concept is called security level. It's work with a concept is called security level. If you talk about Cisco FTD, Cisco Firepower Threat Defense, or Checkpoint Firewall Box, or Palo Alto Firewall Box, so they are working with a technique is called JBF, Zone Based Firewall. But Cisco ASA works with a concept is called security level. So what is security level? Wait. So this firewall device is connected with your LAN network, your trusted LAN network. A switch, and we have a LAN PC, and we have a WAN connectivity.
Right.
So, for example, this interface is fast Ethernet 0/0. This interface is fast Ethernet 0/1. So in Cisco ASA, if you go onto this interface and if you type this predefined keyword, predefined keyword. Predefined keyword is what? INSIDE. It's called inside. Kashif, it's a predefined keyword in Cisco ASA. If you type this keyword, so automatically this interface will get a security level 100. So security level range in between 0 to 100. Minimum is 0 and maximum is 100. So when you type this predefined keyword INSIDE onto this interface, so this interface will get the security level 0. And this interface is an outside interface or public facing interface. So here I'm using anything, your name, my name, anything. For example, I'm using outside. So automatically this interface will get a security level 0.
It's like fixed name.
It's a default. It's a default. I can show you. On firewall, I can show you. Okay.
Yeah.
Right now I'm telling you the concept, but it's a default.
So
inside is a predefined keyword. If you type this keyword, so automatically this interface will get security level 100. And here we are using not inside. You can use any keyword, like for example, outside or WAN or untrusted name. So automatically this interface will get a security level 0. Clear?
So what this means, any keyword? So on the
it's a word, it's a name, only name. You can say name.
But the inside is fixed, like
inside is a fixed. Inside name is fixed.
Okay, got it.
Now by default, traffic is allowed. By default, traffic is allowed from higher security level to lower security level. No need to configure any policy. On Cisco ASA, by default, traffic is allowed from higher security level to lower security level. And remember always only TCP and UDP traffic. Only TCP and UDP traffic. So traffic is by default allowed from higher security level to lower security level. So for example, this inside machine IP address is 192.168.10.1. This inside machine is trying to access outside this server is called 8.8.8.8, for example. So this traffic is going to hit onto the firewall box, right? Onto the firewall box. Now, whenever firewall will receive any traffic, it will verify that traffic is coming from higher security level, right? It can verify. Firewall can verify. Traffic is coming from higher security level and trying to go to the lower security level. And by default, traffic is allowed from higher to lower. No need to configure any policy. So traffic is traveling. Clear my point? Traffic is traveling. No need to create any rule. By default, you can purchase a box, you can add, you can define your interfaces. Done.
It will work.
Yes. But you know, when traffic is traveling through the firewall box, then firewall will maintain the state of connection in a table. State of this connection in a table is called state table, or you can say connection table. In state table, it maintains source IP, source port number, destination IP, and destination port number. So what is source IP address as per this scenario? 192.168.10. What is source port number? So let's take a random port number 52,000.
Correct.
Destination IP is 8.8.8.8. And destination port number, for example, 23.
Right.
So this is the traffic. This traffic is traveling to outside. No problem. And now when the traffic is traveling through the firewall box, then firewall will maintain the state of connection in connection table, you can see, or in state table.
So that means this is the live table, right?
Exactly. Yes. And I can show you on Cisco ASA firewall, I can show you this state table.
Right.
We have a command show connection. I can show you. Now, what about return traffic? Because 8.8.8 will give the reply, right?
Correct.
What about return traffic? Traffic is going to hit onto this interface.
Right.
So now you can see this interface has a security level 0. So onto this interface, we have a security level 0. And now traffic is trying to travel from lower to higher.
Right.
So by default, traffic is allowed from higher to lower.
Correct.
But lower to higher, if you go with the lower to higher, everything is denied.
Rejected.
Everything is denied.
Right.
So now, when this traffic is going to hit onto this firewall box, then firewall, I told you, whenever firewall will receive any traffic, it will verify is this traffic is a part of any existing connection, because I have some information in my state table. I have some connection table in my state table. So now, is this traffic is a part of any existing connection? So firewall will verify, this packet is coming from 8.8.8, and this replies for 192.168.10.1. This is a reply packet. This is a reply packet. The traffic was initiated from inside. And this is just a reply packet. It's not initiated from the outside. Just a reply packet. So firewall will verify, I have a I have a connection information about this traffic. Yes, I want to allow. Okay. So the point is what? Whenever traffic is traveling through the Cisco ASA firewall device, through the appliance, then firewall will maintain the state of connection in connection table and then forward the traffic to the outside. When the reply packet will come, the firewall will verify this packet information in the connection table. If it is available, then allow, otherwise drop.
Okay. So one question here, what if the port is different? Like for example, when the request went from inside to outside, the port number was 52000.
Yes.
But when the reply was...
The reply is from what? Port number 23. Because your request is what? You are requesting for port number 20. Destination port number is what? 23.
Okay.
So it will verify, okay, source IP, destination IP, and what? Port number. As per this information, it can verify, okay, this is the part of my existing connection. How it can verify? It's a part of my existing connection. If traffic is coming from different port number, how it can verify? Maybe this packet is for this inside machine. We have multiple computers. Then how firewall will verify?
Yeah.
This return traffic is for this inside machine. How? Because of source IP, destination IP, and port number.
Yeah.
Because this inside machine, he initiate the traffic for port number 23.
Yeah. Just on this table, because what is happening, source IP is 192, source port is 5000, right? So when I'm looking at source port number 52000, what I'm assuming that 8.8.8 has to respond back to source IP on port 52000.
Exactly. Yes.
So what my question was here, now there is a different port number is there. Like when inside, when LAN was going to outside world, it was using port 23. But when 8.8.8. was replying back to 192.168, it was using port 52000. So what my question was,
then firewall will not allow. Then firewall will not allow. Firewall will not allow. See, the
firewall will not allow. Okay.
Yes, exactly.
The port should also be same, right?
Yes.
Okay, got it. Now it's clear. It cannot change.
Yes.
Okay, got it.
Because behalf of connection table, firewall can verify this traffic was initiated from inside network, and this is just a reply back.
Okay. And reply back, if it is on the same port, then it will allow. If the reply back is using different port, it will not allow.
It will not allow. Yes.
Okay.
Because it's check the information in connection table.
Okay.
So this technique is called stateful firewall technique. Every vendor is using. Every vendor.
Okay.
Now let's talk about Cisco ASA. Wait.
So these slides, I could not receive on email. So
I will send you.
Just got the recording.
I will send you. After the session, I will send. Okay. Yeah. All the. I think I shared with you, Kashif. You can check your mail ID.
No, I checked. I just got the video link, but not this material.
Let me check. Wait.
Yeah.
Let's continue our topic, Kashif. So what is Cisco ASA? Cisco ASA is called Adaptive Security Appliance. Okay, Cisco ASA firewall device is called Adaptive Security Appliance. It is in a combination of stateful firewall and VPN concentrator.
Right.
If you talk about
slides have been shared, because
yes,
I'm just checking my inbox.
Yes, it's available in your drive.
Okay, because
You can check now.
Yeah.
After session, you can check, Kashi. Okay.
Okay.
So now let's talk about ASA features, because every vendor has its own feature, like Palo Alto, Fortinet, Checkpoint, or Cisco FTP. Right now we are talking about Cisco ASA. Let's talk about some features. So these are the features. These are the features available in Cisco ASA Firewall. So first is called operating system. Let's talk about each feature option. So what is operating system? So in Cisco ASA, the software and hardware both belong to Cisco.
Okay.
If we talk about Checkpoint, Kashif, Checkpoint Firewall box. So Checkpoint is a software-based firewall. Software-based firewall. What you can do, you can go onto the Checkpoint website and you can download Gaia operating system.
Okay.
And this operating system you can install on your laptop, on your desktop machine. Okay. And you can use your laptop as a complete firewall.
Oh, okay, got it.
So every vendor had its own option. So but Cisco is what? We have software and hardware, both belong to Cisco. It's not just like another vendor, they use another company operating system, other company hardware. So if you face any problem in software related, so you can talk to Cisco. If you face any problem in hardware, you can talk to Cisco.
Right.
This is the first feature. Software and hardware both belong to Cisco vendors. Now, what is stateful firewall? I told you what is stateful. It's a common topic. So it maintains the state of connection when the packet is traveling for the appliance. It maintains the state of connection in the state table, you can say, or connection table. After adding information in the state table, it forwards the packet to the destination. And when it receives the reply packet, it matches the packet information to the state table. If it is matched, then packet is accepted. Otherwise, now let's talk about next feature. Wait, user-based authentication. So we can implement on Cisco ASA firewall. We can implement AAA. AAA is what? Authentication, authorization, and accounting. So this AAA feature we can implement on Cisco ASA firewall. So using this feature, we can authenticate our inbound or outbound request for Telnet, for HTTP, for HTTPS, for FTP using AAA server. So like, see, AAA we can configure on Cisco router. Okay. Same we can implement on Cisco ASA firewall.
So that Cisco firewall will act as a AAA server?
Yes. No, it's not act as a AAA server. See, AAA configuration you can do. See, here we have a firewall device. Okay.
Right.
For example, Cisco ASA. In case in your organization, see, there is a two option, Kashif.
Right.
Either you can use local AAA server. Your Cisco ASA firewall has a local AAA server. You can create a user account in local database.
Okay.
And you can use it for Telnet service, for HTTP, for HTTPS, no problem. But most of the organization they are using remote authentication server. Okay. Maybe they have a Radius server, or TechX server, or LDAP server. So what you can do, you can integrate your firewall with these remote authentication server. Clear my point?
Okay.
And these are what? These are you can say Radius server. These are remote authentication server, or you can say AAA servers.
Right. Right. So one question here, how generally what we follow, like for example, I have ASA firewall and I have my domain controller, for example.
Yeah, okay.
Now, how can I add this ASA firewall as part of domain controller authentications? So what I mean by that, for example, if you are coming to my organization as a new user, what I will do, I will just create your account on the domain controller.
On domain controller, on Active Directory domain controller.
Yeah, and then you will get automatic same access levels on the ASA. So,
yes,
so how that part is done?
You can do this. What you can do, you can integrate your firewall with Active Directory server.
Okay.
Okay. I can tell you how to integrate our Cisco ASA firewall. It's a very simple task. Okay? It's not a big, it's not a big thing. Okay? It's required few steps, and you can integrate with graphical option. I can show you.
Sure. Maybe
Graphical
we will
option
do
I can
in
show
the
you
lab.
how to. It's not only related with Cisco ASA, Kashif. If you go into the Palo Alto or Fortinet or Checkpoint, you need to integrate your firewall device with domain control or with your remote authentication server.
Right.
Yeah. But my point is right now, you can use your Cisco ASA firewall as a AAA. So you can implement your AAA authentication, authorization, and accounting.
Okay.
Now we can focus on protocol and application inspection. Cisco ASA firewall is not a next generation firewall, but yes, it can inspect the protocol and application, but not on deeper. Okay, but yes, in Cisco ASA we can discuss a concept is called modular policy framework. This is called deep packet inspection. With MPF, using MPF, you can inspect protocol application like FTP, SMTP, DNS, FTP, HTTP, NetBIOS. So these applications you can inspect, your firewall can inspect.
Right. So one question here, like to me, I call them as a protocol, not application.
No, these are the protocols. Yes, these are protocols.
Yes.
But to access FTP service, most of the time we are saying what? FTP application. Open your FTP application and access. It means what? FTP is also application, right? FTP word we are using for application. For example, outside user is trying to access. Sorry, here's a file. Outside user is trying to access FTP server, for example. So what he can do? He can open his FTP application, right? So FTP is an application and FTP is a protocol. Clear? This FTP service is running onto the server. So this is called what? This is FTP protocol. FTP services.
Right.
So don't confuse. Okay. These you can say protocols, or you can say service. For example, SMTP is what? It's also service. It's called service. SMTP service, right? So both are the same application. Right now, you can say application or you can say protocols. No problem.
Okay, so it's not application. Do not mean like
it's a pure application. Like Facebook or like Facebook.
Yeah,
or
it's not like that.
No.
Okay. Now it's clear.
Okay, now wait. Now you can implement VPN concept on Cisco ASA like other vendor. You can go with the site-to-site VPN implementation, or you can say you can implement IPsec or SSL. L2TP is not your topic, so you can implement your IPsec and SSL. In IPsec, we can focus on site-to-site VPN implementation on remote access VPN. SSL, I told you, in SSL we have two practical: client-less SSL VPN and full client. So like other vendors, Cisco ASA Firewall is giving you the feature, giving you the option to configure to implement VPN, IPsec, and SSL. Now we can go with the virtual firewall technique. You can divide your single Cisco ASA firewall device into multiple appliances, into multiple firewall devices, and this concept is called security context. So you can create multiple security contexts. For example, for marketing, we have a marketing context. For sales department, sales context. For HR department, HR context. So context is called what? It's called firewall.
Right.
Okay. Now, the next feature.
So can I say that they are kind of different VLANs kind of thing, like
different? Yes. See, in LAN side, yes, we have a different VLAN, and in every VLAN we have a different subnet. You can say different department.
Right.
You can say, see, for example, let me show you. For example, here we have a Cisco ASA firewall, and this firewall is connected with a switch. And in my LAN side, we have multiple VLANs, you can say multiple departments. For example, this is your marketing department. Maybe you can say VLAN 10.
Right.
VLAN 10. And what you have a sales department. It's called VLAN 20. HR department, VLAN 30.
Right.
And now what we can do for each department, I can divide my single firewall box into multiple virtual firewall box. It's called firewall box 1, firewall box 2, firewall box 3.
Right.
So, and these are the interfaces. These are the resources. These interfaces are what? Resources.
Right, right.
So what you can do now, you can send your marketing traffic to marketing firewall box. How you can send? As per routing switching, you need to put these interfaces, these three interfaces, and this one also need to VLAN 10.
Okay,
right?
Got it.
Because same VLAN members can communicate with each other.
Right.
So you can put these three interfaces and this one also in VLAN 10.
Right.
You know,
right.
Kashif?
Yeah.
Okay. The next feature is what? Like other vendor, you can also manage your Cisco ASA firewall with graphical page. With graphical page. So for graphical page, we can use an application is called ASDM.
Right.
ASDM. See, to manage Cisco ASA firewall device, we have ASDM application. And if you want to manage your Cisco next generation firewall, is called Cisco FTD. So we have FMC, Firepower Management Center. Okay.
So just one question. What's the difference between next generation firewall and this normal firewall?
Okay, no problem. I can tell you. See, your Cisco ASA firewall, cannot detect any malicious URL.
Okay.
Cannot detect any malicious URL. For example, Kashif, I want to block. I want to block this specific URL. Okay. I don't know anything. About this URL, but I want to block it. I cannot block this Cisco ASA.
Oh, okay.
In case, if I want to block all political organizations website, I want to block all news category website. I cannot block this Cisco ASA. Okay. But I can block with any next generation file, like Cisco FTD or Palo Alto or Checkpoint or FortiGate. Okay. Got it. Another example, your Cisco ASA firewall cannot detect any application. For example, in my organization, I want to block Facebook, YouTube, and Google application. Okay. In Google, I want to allow Google, but I want to block Gmail application and Google Drive, for example. Okay, Google Drive. So these are the micro applications you can block with any next generation firewall, but you can't with Cisco ASA.
Got it. And one more point, like what about this IPS and IDS functionality? Because I heard
IPS is related with the next generation firewall.
Okay.
Yes. Got it. IPS is a signature based device.
Okay. So for
example, your Cisco FTD is what? It's a combination of Cisco ASA plus Cisco Firepower. What is Cisco Firepower? It's a NG-IPS, next generation intrusion prevention system.
Okay.
So it's an IPS device. So FTD is what? It's a combination of Cisco ASA and Cisco Firepower.
Right.
Cisco combine these two engine and create a single box. It's called FTD.
Right. So one question, like we normally use Cisco Firepower. So what's the difference between ASA and Cisco Firepower? Like, they are same only.
No. Cisco ASA it's a firewall device.
Right.
But Firepower is a different. It's an IPS engine. It's an IPS device. Here in this box we have multiple signatures. Okay, behalf of signatures, your device can detect multiple attacks.
Right. Because why I'm telling, like we are using some firewalls they are Cisco Firepower series.
Yes. See, Cisco provide you, see, either you can go with the dedicated appliance, or you can go with the Cisco with Firepower service. Okay. Firepower.
Okay.
It means it's a Cisco ASA firewall device with Firepower feature, but it's not a dedicated FTD.
Okay, so like the Cisco Firepower series, technically they are Cisco ASA firewall with firepower capability.
No. Cisco Firepower is a different device. Okay, it's a separate device. Okay. And Cisco ASA is a separate device. But you know, in Cisco, they provide you box. Wait. They provide you Cisco AS. Let me show you an example.
Right.
For example, you don't want to purchase FTD because the cost is very high, but you want to utilize Cisco Firepower feature. Right. So you can go with the Cisco ASA with Firepower. For example, Cisco ASA 550X. If you have any ASA firewall with X option, it means it's a complete ASA device, okay, with Firepower feature. See? So you can use Firepower services with your Cisco ASA, but it's not a dedicated FTD. Clear?
Right.
It's not a dedicated FTD. In dedicated FTD, you will get a different, more functionality you can see.
Right.
But this is a device. It's Cisco ASA firewall. We have a small feature. We can add Firepower feature with our Cisco ASA.
Right. So can you just open the link just to clear my confusion?
Yes.
So it's in the chat. So
this is a Firepower. It's not a Cisco ASA.
This is what type, like?
It's only Firepower device.
Oh, it's a Firepower. Okay,
yes.
Device. Okay.
It's a Firepower appliance.
So, like, technically, any differences there between Cisco ASA and this?
ASA can filter the traffic only based on L3 and L4 packet, IP and services protocol. Here in Firepower, we have signatures. Okay, we have signature database, attack database.
Okay.
So this device can detect and can take action.
Okay.
And Firepower, before Firepower, this is called source fire. Before Firepower, it's called source fire. Do you know about this source fire?
No.
Before source fire, it's called snot. So Cisco, there was a person is called Martin, okay, who developed this snot device. And this snot device you can use as a firewall also, no problem. The source fire you can use as a firewall also, no problem. Firewall features. But this device is dedicated for only source fire, Firepower, IPS feature you can see.
Okay.
IPS feature. So I'm not. Yes.
Yeah, this part is clear. I just want to know, like, the link which I shared, what type it is. It is next generation firewall or no?
Yes, it's not a next generation firewall.
Okay.
It's a NG IPS.
Okay.
It's a NG IPS, next generation intrusion prevention system.
Okay, so I cannot block websites using this firewall, right?
See, you can block. But see, I told you, here we have this device is acting as a NG IPS, because in IPS we have signature database.
Right.
We have a signature database, you can block, no problem. But now here we have a limited signatures. Limited signatures. But now Cisco add this Cisco Firepower plus ASA feature. And they combined this device is called FTD. Otherwise, what? For firewall feature, you have to deploy Cisco ASA, and for NGIPS feature, you have to deploy your Cisco firewall. So no need to deploy two devices.
Right.
Just go with a single box. The single box can provide you both features: ASA, firewall features, all the firewall features, and what? Firepower feature.
Right.
This is not a next generation firewall, you can say. No.
Right.
Clear now?
Yeah.
Okay. Now let's go on to the slide. Wait. Okay, let me show you. So this is the example. Okay, clear? This is what Cisco ASA firewall with firepower service.
Right.
So with any firewall device, if you got X option, it means it's a firewall with firepower service.
Okay.
Now, okay, so web-based management, it's clear. I think we can manage our Cisco ASA firewall with graphical page. Kasif, clear now?
Sorry, I was on mute. Yeah, this is clear. ASDM and CLI. Yeah.
Okay, now stateful failover. Let's talk about stateful failover. What is stateful failover? It's called high availability. In Cisco ASA, you can say high. In Cisco ASA failover concept. In Fortinet, you can say high availability. In Palo Alto, you can say high availability. In Checkpoint, you can say clustering. So we can discuss active standby and remember our previous discussion.
Yeah.
So yes, for failover we can focus on active standby and active.
Yeah, this is clear.
This lab is called active with multi-context.
Right.
Okay? With multi-context. What is multi-context? So we can discuss in our lab. But context is what? Context is related with this virtual file.
Okay, got it.
Okay, now we can also use next generation firewall feature like IPv6. Not feature, you can say it's a next generation IP you can configure on your Cisco ASA firewall. Okay, and what is called next generation firewall? Next generation firewall also support this IPv6.
Right.
So IPv6 is a next generation IP, and you can configure this IPv6 on your Cisco ASA firewall. Like, and we can discuss how to configure IP address on interface, how to configure routing static or default. No problem. Now, clustering is what you can combine multiple. You can combine multiple Cisco ASA device to act as a single device. This is called clustering. A feature introduced in OS 9.0, it enables us to group multiple appliances to act as a single appliance. This is called clustering. So these are the features. I hope it's clear.
Yeah, just 1 second. I don't know. I clicked something, so I'm just seeing my name. I don't know how to. I can see the slide, but as soon as I double click, I just see my name. So can you just reshare again your screen? Yes. Yeah, now it's okay.
So now we can start our basic configuration on Cisco ASA. Wait, let me start on Cisco ASA. Please 2 minutes.
Yeah. So one quick question, like, do you have courses for VAPT or no?
Sorry, for?
VAPT, vulnerability assessment and penetration testing.
Yes, I have.
Oh, okay. It's practical, right?
Yes. If you want, so I can send the syllabus, no problem.
Yeah.
Sure. And if you want a demo, so I can arrange a demo session with trainer.
Okay. So, that is by someone else, not by you.
Yes.
Okay.
We have 7 trainers in this. Okay.
Right.
7 trainers. So I'm taking all the firewall batches.
Okay.
For routing switching, we have 2 other trainers. For ethical hacking and cybersecurity, and for CompSIA, for pen testing, different trainer, and for software technology, So we have 7 trainers in this company.
Okay. Okay.
Okay, so we have a single Cisco ASA firewall box right now, okay, for basic configuration.
Okay.
So I have a Cisco ASA device. You can start. This is a console page. And we are working with 9.x operating system.
Right.
Please wait, this will take time.
Right.
Okay, Kashif, can you hear me?
Yes, I can hear you.
So this is what the user EXC mode you can see. We are in
Okay.
Cisco ASA firewall device. Here you can type enable command. You press enter. It's asking for a password, but there is no any password. You can press enter.
Okay.
This is your privilege mode, you can say. And now I'm using a command. If you are familiar with the Cisco router, so show IP interface, this command for IP address information. If you press enter, we are facing problem.
Okay.
So here we can use show interface IP page. There's a little difference in command.
Okay.
Show interface IP page. So you can press enter. You can see we have 4 interfaces right now.
Okay.
First command, you can go with this firewall box. Is called show firewall to verify your firewall mode.
Okay.
So the firewall mode right now is a router. It means this device is acting as a layer 3 firewall. Layer 3.
Okay. Okay.
Okay, so you can verify some license information also onto this device.
So one question here, like I know about layer 2 and layer 3. What is layer 4?
No, this device, see, this device is a layer 2. It's a mode. See,
right.
It's a mode. You can deploy your, see, there's two kind of device you can deploy in your network, right? Either you can use your device as a L2,
correct,
or as a L3. L4 is not a device, it's a service.
Okay.
It's a service you can use on a device.
Okay, got it.
So L4 is a different thing, okay? L3 and L4 is a device mode. L2 is what? Like a switch.
Yeah, L3 has like routing capability, yeah.
Okay, so now you can type show version command to verify your license information. So, or you can say for some other information. So we are working Cisco ASA appliance. Software version is 9.1.
Okay.
And ASDM version we can use 7.3 here. We are using. And hardware is what? ASA 5520. So let me show you some hardware product series.
So this application, like you will be helping, right? How to set up
Yes,
this
yes.
AV application, yeah.
Yes.
Because I know it's like Cisco packet tracer, right? But it is like more graphical kind of thing.
I will tell you, no problem. Okay, so let's talk about some product family in Cisco ASA. Okay, so these are the Cisco ASA product family. Like series start with the 5500. So these series 5505, 060, 10, 12, 15. These series you can use for any small office or branch office. Okay.
Okay.
You can go if you want to go for the medium size of network. So you can go with a 5520. 5520. And if you verify here, we are working with 5520. 5520 series of the firewall box you can use for medium-sized network, medium-sized office, or internet is security appliance. If you get X option with any firewall device like Cisco ASA 5525X, it means we have a firewall device with firepower feature. Clear?
Okay.
Firepower feature. But it's not a full feature, okay? Because for full feature, we can go with the dedicated appliance. It's called Cisco FTD.
Right.
Now, okay, these are the medium size of the firewall device. Medium size of the firewall device. For large organization, you can go with the Cisco ASA 5550. And for data center, you can go with the 5585X. And if you have ASA with a small v, ASA firewall device with a small v, so it's a complete Cisco ASA firewall device. It's a complete ASA, but this ASA you can use in a virtualization scenario. Clear? You can use in a virtualization scenario. This
so
is a complete
what we mean
like
by
AWS, Azure, AWS, okay, VMware cloud deployment. You can use this ASA. It's not a physical device. It's not a physical device.
As a virtual appliance, you mean?
Yes, virtual.
Okay.
Like in case if you are working with AWS or Azure cloud scenario.
Yeah.
So for clouds, you require a virtual firewall. So you can purchase this Cisco ASA V.
Oh, okay. Got it. Others are physical.
These are the physical boxes.
Okay, got it.
Okay, so now here you can so you can verify your hardware model, RAM, CPU information, and here we can get some license information. For example, maximum VLAN 100 we can, and for failover we have a license for active. We can implement active passive and active.
Right.
For VPN, yes, triple dash and dash is available, so we can configure VPN option here. We have a license. Right. For virtual firewall, yes, we have a license onto the Cisco ASA box. Right. We can divide our single firewall box into 20 firewall. So we have 20 security context license. Clear my point?
Okay, yeah.
So you can get license information here. Now.
So one question, like yes. When we order this product, how the license part is ordered? Like
you can talk to your salesperson, okay? They can suggest you. For example, you don't want VPN implementation onto this device, so no need to purchase license.
Okay.
If you don't want to implement VPN, so no need to purchase. You can talk to salesperson. They can help you. They can tell you the requirement.
Yeah.
First your requirement.
Sometimes it's reverse. They ask, okay, what do you need? Tell me.
Yes.
Sales guys, they don't know technical things. They say, okay, this is complete list. Please tell me what you want. I will give you price.
Yes, sometimes yes.
So So they generally push back things to us back again.
So that's why I'm telling you, as per your requirement, you can purchase. Okay. First, you can identify your requirement. For example, you want to divide your single firewall box into 10 firewall box, so you can purchase security context license. Or you want to implement a failover, so you can go with the active license.
Okay. And license, what is license? It's a file or it's a serial number?
It's a key. It's a key.
It's a key. Okay.
I will show you how to install license. No problem.
Yeah. Because it's important.
See here we have a command. I can tell you. See, let's go into the configuration and activation. Activation, say question mark. Activation key. I can tell you how to install any license. Okay. Kashif, let's continue our topic tomorrow. Okay.
Yeah.
10:30. So let's continue. I have another batch.
Sure.
We can continue from here.
Yes.
Bye, Kashif. Take care.
What about recording you will send?
I will share. See, I have another batch. Okay. I will be free at 12 p.m. So 12 p.m. So I will share in 2 hours.
Okay. Thank you. Bye.
Bye, Kashif. Take care. Good night.
Good night.
Can you hear me?
Yes. Now I can hear.
Okay. Let's start our topic, Kashif. Okay. Now.
Sure.
Okay. So remember our previous discussion. I'm going to start our basics configuration on Cisco ASA. Okay. Let's just start the basic configuration on Cisco ASA.
Recording is started? Or?
Yes, it's started. Yes.
Okay. What about my lab setup? Like when on
we can set up today if you want.
Okay, so
if you want starting.
Yeah.
Now recording start. Now you can install WinSCP. Go into your download folder and install this application. WinSCP. Yes, install for all users. This is just a FTP application, Kashif. WinSCP we are using to upload and download images.
Okay. From where?
We can upload images through this application in EVNG.
Oh, okay.
Yes.
So through this application,
you can upload the images in EVNG. You can upload firewall images in EVNG.
Upload anything from my computer?
Yes, from your computer to EVNG. Now click on finish.
Yeah, done. So we installed.
Okay, now wait. Can you wait? Please allow remote control request.
WinSCP.
Please allow remote control request. Now wait.
Is recording not started yet? Recording
started.
Okay.
WinSCP, WinRAR, Windows. It's EVNG client pack and EVNG disk 1. Can you open your download folder again, Kashif? Can you open download folder? Download folder.
Yeah, it's down.
Okay. And
yeah, this is download folder.
Wait. Let me do this. not pass OVF.
I think it was still downloading. Disk is done or not yet?
I'm not sure.
Just,
can you
just
please check? Can you please check?
Yeah, because this was the biggest file. So it failed. Windows 7 is failed.
And Windows VMDK file? VMDK
also failed. Also failed. Let me try again.
It's a big file. That's why. It's
Yeah.
a 14 GB file.
So this one, right? I have to download again.
Yes.
Okay.
And this EVNG disk one. EVNG disk.
This one, right?
Yes.
Okay. Failed. Why? Maybe I have to, I don't know. Any issue with these files?
I think maybe some space issue. Can you check your space in C drive? Kashif, please check disk space in C drive. Kashif, can you hear me? Hello? Hello?
Yeah.
Wait, it's downloading. Wait. Sir, I mean, see, 10 seconds. Wait.
Okay.
Can you please allow remote control request? And wait.
Let me just refresh. Yeah.
Wait. Okay. EVNG disk. Number 7. EVNG. Please put all these files in a folder. Rashid, please create a folder in D drive, like software something. No, paste it here.
What about other files we don't need?
No, not required.
Okay.
Okay, so EVNG is VMD. VMDK file.
The first one. So especially what happens, the people from Middle East, there are no taxes. So technically they have a lot of money to spend on the trainings. But especially in North America and those things, what happens, the taxes are very high. So whatever you earn, you lose on taxes. So it's like very, very difficult to take out some funds from personal pocket for any training. So maybe, I don't know, 35% taxes are there.
In US, Kashif?
In North America, especially Canada, they take like they are the highest in terms of taxes. Even in US, taxes are less, but in Canada, like they really kill people in terms of taxes. And again, the cost of living is much, much higher as compared to Middle East. So
I don't know too much about
like
this. So I have some student from Canada.
Right.
No, it's imported. So it's working.
Yeah. So how did you import it? Like just right click and then?
Just click on OVF file. Double click on OVF file. It's automatically attached with VMware.
Oh, it will open automatically.
But you require 3 files. You require 3 files: EVNG MF, EVNG OVF, and EVNG disk.
They should be there in that
yes, it should
location.
Be there, yes.
Okay. Then it will know automatically like all these files are there and I should start import.
Sorry? Yes, Kasim?
Like how it knows like now I have everything and it's good to import.
It's because you know, if you don't have, so it will not start. Okay.
It will give some error.
They are related with each other.
Oh, okay.
And Kashif, I'm sharing one image. So please download it. One Cisco ASA. I'm sharing 9.7 image. Latest Cisco ASA firewall image.
On Google Drive, right?
Yes, I'm sharing.
Okay.
I'm sharing it. Now please check on your side. Refresh your Google Drive. Yes. Yes, this is this one. ASA 9915. Yes, this one, this file. Download. And the second image, ASA 971. So these images we can upload. Okay, please open google.com. Google.com. Google.com and download WinRAR. Type here WinRAR, download. WinRAR, WinRAR.
WinRAR, I think I should have.
If you have.
No.
No.
Okay.
(64-bit), click on this. No, this one, this 64-bit.
This one, right?
Yes, 64-bit. And install this application. Install this WinRAR application.
Okay.
Install. Okay. Now go on your download folder and copy these Cisco images and these files you can put into the same folder. Now right click on ASA 915 and select wait. No, click on show more option. That show more option. What's not happening?
Want to extract or what?
Yes, I want to check.
Yeah, just
same
open
bit.
with WinRAR. It will ask. Yeah, just extract to the second from the top. Yeah. Yeah.
Actually, this
then,
option not
yeah.
showing. Otherwise,
Yeah. It went directly on D drive. Yeah, have to copy. Yeah. Just drag down. If you can just click extract to, it will directly go there. Yeah, because the path is already there. Yeah.
yes, yes.
.971 you also want to extract?
Yes.
971.
No, you can go on your VMware workstation. Wait. Okay, wait. Let me do this. So you can see, we can click on edit and let me check RAM.
It's 16 GB in my PC. Yeah.
So we can expand the RAM here with 10 GB bucks. We can add one more hard disk. And no need to change anything, Kashif. Okay. These are the bridge, so it means
bridge means it will be connected with my computer, right?
Yes, computer. Yes.
Okay.
Now you can power on. Click on power on, Kashif. Click on power on. Now this will take time. Can you please open command prompt now?
On my PC or on VM?
Yes, your PC. Command prompt. ipconfig. ipconfig. So you can see here on your Wi-Fi LAN card, you are getting 192.168.1 series IP, right?
Correct. Correct.
Same series of IP address you will get here. Same series of IP.
Sorry?
Same series of IP you will
Yeah.
get here in EVNG. See,
Oh,
1.190
automatically.
automatically. Yes.
Okay, okay,
Now
great.
open your browser. Open your browser.
Yes.
You have Google Chrome, something? Kashif, you have Google
Yes.
Chrome?
Yeah.
Please open Google. Now 192.168. Type here 192.168. 1 dot, I think 194. I think 94, I think. Only 94. Enter. Yes. Username is admin.
Yeah.
Admin.
This
And
recording
password.
is working, right? Just
Yes,
in case
recording
I
is working.
forgot.
Yes, yes,
Okay.
I will share. Username is admin. Password is EVE. EVE. Yes. Sign in. Click on sign in. Sign in. Just click on sign in. Now you can create your topology. Let me do this. Okay.
Right.
So here you can create. See, add a new lab. You can click here. Whenever you want to create any new lab, you can create it. You can click here and create a new lab. For example, Cisco ASA lab 1.
Okay. Okay.
Click on save. Now you can right click onto this blank screen and select your mode.
Okay.
So you can see here you have a Cisco ASA.
Right.
Cisco ASA 9. So this is the default. Okay, Kashif. You can use it, no problem. But in case if you want to upload any other Cisco ASA image.
Oh, okay.
So now you can open your WinSCP.
So ASA image means what? Like if I have this Cisco firewall at site,
Cisco ASA firewall
I can
Cisco,
open here that backup.
Yes. See, here we have our Cisco ASA images. These are what 9.1. Okay, 9.7. These are the other Cisco ASA images.
Oh, so images means like the
firewall
real firewall configuration.
Yes, it's a real firewall. Yes, it's a firewall.
Okay.
So you can upload these one if you want. So let's upload.
So same way I can bring my site configuration and I can import, right?
Yes,
just to play with it, right?
Yes. Configuration. We're talking about configuration.
Yeah, I don't know, like whatever comes out from the ASDM. So I use ASDM normally to do my day-to-day stuff.
Okay.
So
see,
I don't know how.
Show you. Akash, give me some time. Okay, I will show you.
Sure.
So it's 1.90. Let me upload this first. 94. Okay. Username is root here. Whenever you want to upload any image, username is root here. Kashif. Password is EVE same. Click on login.
So what we are doing in this one, like from
we are uploading our images, our firewall images into this application. Into this application. But right now we have a default Cisco AS image.
Okay. So when we entered .94, technically we are accessing VM now.
Yes.
EV now, right? EVNG.
And in EVNG we can create our topology.
Okay.
We can create our lab topology for practice.
Okay. So now you will move those files into here, right?
Yes, into this application.
Okay. Into .94.
Now OPT, unit lab, add-ons, QEMU, and now I'm trying to upload images. So training software. So I can upload this ASA folder. Just drag your folder this side.
Okay.
Click on OK. 9.7 I can upload this one. Done. Once you upload any image, for example, Cisco ASA, now I'm trying to upload this Windows 7 image. It's a big file. It's a big file.
We need here on that. We
Windows
need 7, that on
Windows 7
.94.
Yes, sorry. Yes, in EVNG.
We need this on .94.
Yes,
okay.
Yes. We are trying to upload all the application, all the software into this EVNG.
Okay.
And through this,
so this EV, this EV application, it's not Windows based, right?
No, it's like it's an application, separate application.
It's an application. So can I say that when This is kind of, I don't know, it's a virtual appliance.
It's like a packet tracer.
Right. But
Remember,
what my question?
in CCNA, it's a packet tracer. You can create, you have images, routers images, switches images, right?
Yeah. But what my question was, this is not a normal Windows machine, right? If we open, it's coming just like a ESXi host, right?
Yes.
So so it's operating system, right?
Yes,
Of
it's EVNG. Yes.
Okay, got it. So it's on what, Linux? I don't know, Unix or what?
It's a Linux.
Linux, okay. So any reason that I think this application comes as a Windows also, no?
See, you are using this application in VMware.
Okay.
You are using this application in, see, it's just an application, or you
Right.
can say EVNG disk, and this application you can upload in VMware. You can upload in VMware.
Right.
And with this application, you can create multiple topologies for firewall, not only for Cisco. If you go onto your browser,
right.
If you go onto your browser, you can see you have multiple devices options. See, click on node.
Right.
Aruba, okay, ASA. But
Right.
these are not highlighted because there is no image right now.
Oh.
If you want to do switches lab, Cisco switches lab, so you can click on Cisco IOL. Here you will get your Cisco switches images.
But gray means what? How can I get them blue? Like,
see, you have to upload it. You have to upload the images. Okay. Right now, we are uploading Cisco ASA image. Right?
Okay. And just for my information, from where you got those images? Like they are available?
I have. I purchased these images.
Oh, we have to purchase. Normally we cannot. It's not free.
Yes, no. And I'm sharing with students.
Oh, right. So it's not like something I go on Google, download image free, and then just import.
See,
upload.
you can get, but you will not get a license.
Oh, right.
Now see, we have ASA 9.1 properties. You can set 777. Click on OK. So you need to go on each images. So we uploaded these 3 images, so you can select 777 permission. Now Windows 7 properties. Now just close this application. Done. Now you can refresh your page, and you can right click node. You can select your Cisco ASA or ASAB, for example. Now you can just click on save. Now you have a Cisco ASA image. You can add your window machine if you want, for example, Windows 7.
Oh, so only that I can get, like whatever is removed. Okay.
Yes.
Okay.
Now you can add your machine.
So these devices, they come by license only, right? Like in general.
Yes, we have a license.
Okay.
So now what we have Cisco ASA, and this is connected with this management PC. It's a complete machine. See, you can right click and right click onto this window machine. And it's a complete Windows 7 image. See, you can open.
The screen will come here.
Complete operating system. See?
Oh, it will come here. Okay, good.
Windows 7. And now you can double click on Cisco ASA. You can get Cisco ASA image. Console page. This is console page.
Okay.
Clear, Kashif? Your lab setup is done.
Yeah. Right. Okay. So this like CLI, we are opening through CLI, right?
Yes, it's a console.
Okay.
Kashif, let's continue this topic tomorrow. Okay, I have another batch. Okay.
Sure.
Bye, dear. Take care.
Please share the recording.
Sure.
Okay.
Bye, dear.
Hi, good morning. Yes, I can hear you.
Hello, Kashif. Can you hear me?
Yes, I can hear you.
How are you, dear?
Yes, I'm doing good. How about you?
Good.
Great.
Let's just start our discussion now. Sure.
Yes, so I could not get second recording, so I just got one recording. So when we did the lab setup, that recording I still could not receive.
Yeah, I will upload today, okay, after this session.
Okay.
Okay, so let's start our discussion and we check session meeting. Okay, so we have completed our telnet and SSH configuration on Cisco ASA firewall, right?
Right.
Okay, now. So let's talk about the next concept is called routing implementation on Cisco ASA firewall. Kashif, this is our topic, routing implementation.
Right.
So for routing, if we talk about routing concept, so we have three methods to implement routing. The first one is called static routing. Second, we have default routing, and third is called dynamic routing.
Right. So just one question, like in last classes we were doing like outside, inside. We tested ping as well. So that was the topic, right? We done that.
Yes.
So this is after that, right? Just to
Yes.
make sure.
Yes.
Okay.
So now, see, in previous session, the topic was telnet and SSH.
Right.
It means to the firewall.
Right.
To the firewall. Now,
Exactly.
now we are talking about through the firewall traffic.
Okay.
And for through the firewall traffic, we need to implement routing configuration.
Okay.
Because it's L3 device, and we need on L3 device we need to configure routing. So you can go with the static, default, and dynamic. In dynamic, we have option EIGRP and OSPF configuration.
Okay.
So for routing configuration, I'm using a small topology. This is our topology for routing configuration.
Okay.
Let me explain you. This is a Cisco ASA firewall. We have inside network, outside network, and DMG.
Right.
So this is our topology. And for routes, I'm trying to create some loopback. Right? So 1.1.1/32 on R1 side.
So I don't know what this loopback means.
Loopback,
What is
we
loopback?
are using for testing purpose. Okay.
Okay,
For
so
routes.
that means we don't have to add machine?
No. Yes, exactly.
Oh, okay.
Yes.
That's why we are adding this. Okay.
Yes, loopback. This loopback is acting as an inside machine.
Oh, okay.
Inside machine. Now 3.3.3.3/32 on outside router. So on every device, inside router, outside, and DMG, we have a loopback. So let's start our basic configuration. So let's configure a router 1 inside router. You can see as per our topology, we are using fast Ethernet 0/0.
Right.
So I'm configuring IP address. So right, for subnet we are using 200 network. So fast Ethernet 0/0, 200, 200, 210 I'm using 255, 255.0, no shutdown. This is fast Ethernet 0/0 configuration. Let's create loopback. So interface L0 loopback and IP address 1.1.1 IP address 1.1.1.1/32, single IP address. Now show IP interface brief. You can see you have a one physical interface and one logical interface.
Okay.
Let's go on to the DMZ router. No. It's a DMZ. Now fast Ethernet 0/0 IP address as per our topology 10.1.23 network. 10.1.23.10 I'm using /24, no shutdown. Exit. Let's create a loopback on DMZ router. Interface loopback 0 2.2.2.2/32. Show IP interface. So one physical interface and one loopback interface. Let's go on to the R3 outside router. Ten dot one dot 32.10/34. Now let's create a loopback. So interface L0 3.3.3 and mask. Now we can configure our firewall device. Cisco ASA firewall. So show interface IP brief. We have three interfaces: Ethernet 0, Ethernet 1, and Ethernet 2. Let's configure. Ethernet 0 is acting as an inside link. So name it inside. IP address 200.200.1/24. No shutdown. Now interface Ethernet 1. Name it DMZ. And security level I'm using 50. IP address 10.1.23.1 255.255.255.0/24.
Okay.
Now interface Ethernet 2.
Right.
Name if outside. IP address 10.1.32.1/24. Basic configuration is done.
Right.
It's a basic configuration. You can verify your IP address information. Okay, so in Cisco ASA firewall, the good thing is what we can use show command anywhere.
Okay.
Show command
anywhere. No need to go back in
privilege mode. Yes.
Okay.
So here we are here in global configuration mode. So you can type show interface IP brief. We have three interfaces: show name if, show name if. So we have three interfaces: inside interface now, DMZ interface, and outside interface. And these are the security levels. Now you can verify your routing table information right now. So with show root command, you can verify your routing table. So right now we have only directly connected interface information.
Right.
If you check here, we have what? Only directly connected. 200 network, 32 network, and 23. See?
200. Yeah. 200.
Now, yes.
23, 32. Right.
Yes. Now let's configure routing option here. So I'm trying to implement static routing first. Static and default routing.
Okay.
So how to configure, routing concept on router? This is not our task. Our task is what? How to configure on firewall.
Oh,
because we all know how to configure routing on router from CCNA classes.
Exactly.
So let's focus on firewall. But for complete connectivity, yes, I will configure routing on all devices. But our focus is on firewall. So we can configure static routing and default routing. So I'm here on firewall. So for LAN side, I'm trying to configure static routing.
So on a high level, what's the difference between static routing and default? Static, I know.
Static is what? Static we are using
Fixed.
for, yes, it's a fix. And if we know the destination address, we can create an entry with static net, static routing option. But the problem with the static net, we cannot use in a big organization. Okay, if we have a small network, so we can go with the static routing. In a small default routing, we are using most of the time for ISP.
Okay.
For example, here in cloud side, we don't know how many destinations. So we are telling what, for any unknown destination, this is my gateway, my ISP. For any unknown destination, this is my gateway. So most of the time, okay, default routing we are using for ISP side. So this is our task for inside network. I'm using static. For DMZ static, and for outside, let's configure default routing. Clear the task?
No, this default. Yeah, this default. So who is ISP in this triangle?
This our router. This outside router. This outside router is acting as a ISP router. Okay, so after ISP, what we have? This destination.
Okay.
This R2 is acting as a gateway, ISP gateway.
Okay.
So I will configure default routing towards this gateway. And for destination address, yes, we have this destination address on R3 router, 3.3.3. So for connectivity, we can try connectivity with 3.3.3 network. Clear now, Kaushik?
Right.
So so this is our task.
But that rule we will add in firewall only, right?
Yes.
We will not do anything on this ISP router.
No, we will see. We will configure on every devices, okay? But our main focus is on firewall.
Okay.
So what I'm doing, on R1, R2, and R3 for basic connectivity, on R1, R2, and R3, I'm trying to configure default because I don't want to create a static entry on router, because we all know how to create static entry or default entry, but I don't want to create on router because our focus is on Cisco ASA firewall.
Right.
So from R1, R2, and R3 towards firewall, I'm configuring default route. Okay. For example, from R1 to firewall, I'm configuring default routing. Any network, this is syntax. Any network, any mask, 200, 200, 200.1. Done. Now let's go to R2. Any network, any mask, 10.1.23. From DMZ route.
Right.
R3, you can see IP route, any network, any mask, 10.1.32.1. Done. Wait. Done. So now let's focus on static default routing configuration on Cisco ASA firewall here. So you can verify with show route command. You can verify that right now we have only directly connected interfaces, directly connected routes. So as per our topology, I'm trying to configure a static routing for inside network, for DMZ network, but for default, for outside, I will use default routing. So how to create entry? You can go into the global configuration mode. Command is what? Root. On router, command is what?
Route, yeah.
IP route.
Right.
On routers, you can use a command IP route. Syntax is same. But here we have IP route on Cisco router. On firewall, you have root command.
Just the route. Okay.
Now, question mark. If you type question mark, you need to define your interface.
Okay.
So you are trying to create static and default routing. Perfect, no problem. But please tell me for which interface.
Okay.
So I'm telling what I'm trying to configure routing for inside network.
Okay.
And in inside network, I have a loopback 1.1.1. This is my destination address. I want to create a static entry for this destination address. If anyone trying to go 1.1.1.1, okay, and this is mask. This is mask.
Okay.
It can go via 200, 200, 200 dot. This is entry.
Can you explain
on firewall.
this
I'm on
command?
firewall. If anyone trying to go 1.1.1,
okay,
so they can go via this gateway. This is static entry. What? Its syntax is same. See, destination information. This is what destination and information. And next hop IP.
Hop.
Next hop IP.
Got it. Clear.
Okay. Now you can click on. You can press enter. You can press enter. This is our first entry. Now let's go up with the route. DMZ. Now 2.2.2.2 because we have a loopback 2.2.2. 255, 255, 255, then 10.1.23.10. Again, if anyone trying to go on 2.2.2, they can go via this gateway. Here we are using 10.1.23.10. Clear now? Kashif?
Clear. Yeah.
Now let's configure default route. So route outside and any network, any mask, any network, any mask 10.1.32.32.10. So what I'm saying, if anyone trying to go any unknown destination for 1.1.1, please use this gateway. For 2.2.2, please use this gateway. But if anyone trying to go any other destination, any unknown destination, so they can go via 10.1.32.10.
Okay. So by here, anyone means we are talking about DMZ and inside network, right? Technically.
Any means what? Any destination. Now, if you, let me see. Now, if you verify this time your routing table, so we have 3 entry.
Okay.
We have 3 entry. As per this configuration, see, we have 2 entry with S. S is called what?
Static.
And 1 entry with S is asterisk value. It means asterisk value means what? This is candidate default. It means this is static default. Default route. So if anyone, as per my configuration, as per entry, if anyone trying to go on 1.1.1, so they can go via this gateway.
That's correct.
In your firewall, you have an entry. If any traffic, firewall will receive for 1.1.1, firewall will send this traffic on 200, 200, 210. Now, if anyone trying to go 2.2.2 can go via 10.1.23.10. Now, if anyone trying to access any other destination, not 1.1.1, not 2.2. If anyone trying to access any other destination, any unknown destination, so they can go via ISP set. Okay. Clear now?
So this line means any IP,
any
destination.
Exactly, any destination.
Okay.
But right now into this small topology for testing, we have a loopback 3.3.3.3.
Right.
So let's go on to the firewall now. So if I have a route, in my routing table, so I want to verify my connectivity.
Yeah, but so in this one, just for my clarity, because the packet will first come inside the firewall, right?
No, right now, I'm trying to initiate my traffic from firewall.
Okay.
I'm not initiating traffic to the firewall. Right now, I'm here.
Okay.
Right now, I'm here. I'm trying to ping my 1.1.1, 2.2.2, and 3.3.
Okay, got it.
So let's verify, because I have some entry in my routing table. So let's verify connectivity.
Yeah.
Ping 1.1.1. Yes, I'm getting reply. Success rate is 100%.
Okay, that means our rule is okay.
Exactly. 2.2.2. Yes, I can ping. Now ping 3.3. outside loop back. Yes, I'm getting reply.
Okay.
Yeah.
Right.
But now let's go on to the inside route. Let's go on to the inside route. So you can verify onto this inside router with show IP route command. With show IP route command, you have a default route, right? We are not using any static entry. You can configure, like if on R1 you can configure this destination information, then next hop IP, then again you need to create one more entry for this destination, again gateway same. But we are using here what? Default route. So for any destination gateways 200, 200, 200, 1. Okay. For any destination gateways 200, 200, 201. So now I'm trying to initiate my traffic. So on R1, I'm trying to ping 3.3.3.3. It means I'm trying to travel through the firewall, right?
Right.
So this traffic, say if I will generate this traffic, then source is what?
Source is the one.
Source is this exit. No. If you want to ping from 1.1.1, so you need to specify with source command 1.1.1.
Right.
If you ping 3.3.3 directly, so it means you are trying to ping from this exit interface.
This exit interface, correct. 0.0. Yeah.
So IP exit interface is what? 200, 200, 200.1. Here we are
10.
using 10, right? 10 we are using. Now this traffic is going to hit onto the firewall box. Now what firewall will do? If any traffic is going to hit onto the firewall device, then firewall hit. Okay, so this traffic is going to hit onto this firewall device. Now firewall will receive, okay, you are trying to go on 3.3.3. Let me check my routing table. In my routing table for 1.1.1, this is gateway, 2.2.2, for this is the gateway. Okay, for 3.3.3, I don't have any static entry, I have a default entry.
Right.
Okay, so for 3.3.3, yes, this is the part of my any unknown destination. So you can go via 32.10. So this firewall will forward this traffic to the outside router. Clear?
Okay.
So it's a simple routing switching concept.
Right.
So now if I'm trying to ping, for example, I have a route, and as per my routing table, I'm waiting for reply.
Correct.
But I'm not getting reply. See, success rate is what? Success rate is 0%. So I'm not getting reply. Why? See, if you remember, I told you we are working with Cisco ASA firewall, right?
Right.
And on Cisco ASA firewall works with a concept is called security level.
Correct.
By default, traffic is allowed from higher security level to lower security level by default. Right. But remember always, only TCP and UDP traffic.
True.
And this is what, Kashif? This is ICMP traffic.
ICMP, correct.
ICMP traffic. So higher to lower, it's allowed, no problem. But only TCP and UDP traffic. But this traffic is ICMP. It means from this inside machine, you cannot ping to your loopback. You cannot ping.
Right.
But wait. If you go on to the R3 onto this outside router, or you can say on R3, I'm trying to enable telnet. Line VTY space password Cisco log. Now, host name is ISP. Now, so I cannot ping, but in case if I'm trying to access telnet is a part of TCP connection, right?
Correct. It should work.
So now, if I'm trying to access telnet, same IP, get 3.3.3. See, the good thing is what? I cannot ping, but I can access telnet.
Right, because TCP.
TCP connection. So password is CISCO123. See,
okay.
ISP router.
Correct.
Now, if you remember, I told you if traffic is traveling through the firewall device, if traffic is traveling, right?
Yes.
I'm on R1. Okay, I can access this outside route. Traffic is traveling through the firewall device.
Correct.
So on Cisco ASA firewall, if traffic is traveling through the firewall box, then firewall will maintain the state of connection in a table is called state table.
Right.
And in state table, what we have? Source IP, source port number,
right,
destination IP, and destination port number. So this is that was a theory concept, right? Remember?
Right.
Traffic is traveling through the firewall box, and firewall will maintain the state of connection in connection table. When the reply packet will come, firewall will verify this packet information in a state table. If there is any entry, traffic is allowed. Otherwise, no.
Right.
So right now, this traffic was initiated from inside network, and so it's allowed. So now let's verify our state table. Our state table on firewall.
But in this case, source port and destination port will be same, right? It won't change.
No. See,
it will change.
Okay. See, let me show you the entry. Okay. Show connection. Let me show the show connection command. You can verify your state table entry. What you have in your connection table.
Okay.
So this 210, this inside PC is trying to access what? 3.3.3. And source port number is a random port number, but destination is Kashif 23. Telnet port number is what? 23.
Yeah.
Clear. So what we have in our connection table.
Just 1 second. Just let me just read this line. Okay. 200.
I can explain you. See.
Okay.
This is what TCP connection.
Yes.
And now this is what source IP. This is what source IP, source port number.
Correct.
Destination IP and destination port number.
Okay.
Yeah.
Got it. So one question here, like how the communication works if it is 25523, but finally it's 23. So how it knows, like
this is source IP. This is source IP. See, when traffic is traveling, if you remember basic routing concept or basic packet flow on router.
Correct.
Basic packet flow. So what we have, if traffic is traveling, so what it's required source IP.
Oh.
For example, if I'm trying to ping google.com right now, so my source IP address is what? My source IP right now is 192.168.1.4, right?
Right.
And now automatically I need a source port number. So it's a random port number.
It's always random port number?
Yes, it's random, exactly. Yes, it's always random.
It's not like 23, like
no. See, this is for destination. It's a fix because you are trying to access telnet service.
Okay.
Telnet standard port number is not. It's a fix. I'm talking about this source port number.
Okay.
So this my laptop, if I'm trying to ping, if I'm trying to ping google.com,
right.
So I have my source IP 1.4 and automatically it will take a source port number, any source port number.
Okay.
But what about
for the ping to go through? For the ping to go through?
Yes, and see, for example, if I'm trying to access Telnet, for example, Telnet,
right,
google.com. So my source IP address is 192.168.1.4, right? This one.
Correct.
And my source port number is any random port number.
Okay.
What about destination? Destination is Google IP.
Right.
Destination is Google IP and destination port number. I'm trying to access Telnet service. So this is my destination service.
Okay.
Destination port. So this is the syntax.
Okay.
So same information. This same information. The good thing is what, Shiv, we can see this information in firewall. We cannot see in router.
Yeah, that's correct. That's why what I was thinking, like it's 23 source as well as destination.
Yes. And see, router will not maintain any state of connection, but firewall can. So we can see this state connection in firewall. Clear now?
Right.
Okay, now so here we can see the connection table. Now, if I'm trying to exit, for example, exit. So connection is closed. Again, this time if I'm trying to verify my connection table, so traffic is not traveling through the firewall device, so I don't have any entry.
Okay.
Clear now? Yes. Entry is gone because I don't have any connection.
Okay.
So when traffic is traveling, firewall will maintain the state of connection. Clear now?
Yes.
Now let's generate again, for example, telnet password Cisco 123. I can access and you can verify. This time you have a different port number. Previous, see, source port number is a random port number, but destination is fixed because you are trying to access telnet service.
Right.
Now exit. So traffic is traveling.
So just one question here. Like generally when I'm configuring the rule, I tell few things only, like source IP, destination IP, and port number, which is normally 23. Generally in firewall rule, we don't define this random ports. So within the firewall,
you cannot
how
define
it works?
You cannot define this random port on any device.
Right.
It's automatic.
Okay, so can I say that in firewall, like when we are going towards 3.3.3, so anything will go, like any random port the firewall will allow, right?
Yes.
Okay.
If you are not only 3.3.3, if you are trying to access any destination, so destination IP address is fixed. Destination port number is fixed.
Correct.
Source IP address will change.
Okay. And firewall will not
source IP,
look
source
at all.
Port number.
Source port, yeah. And firewall will not look at that port technically, right?
Yes.
Okay.
Clear now?
Clear.
Okay. Now, so wait. What was your question? Firewall will not look at the source port.
So
no. See. Every connection has a port number. No. Wait. For example, Kashi, there is two machine.
Correct.
Firewall will maintain also the source ports. It's important. Because with these two computers, if they are trying to access telnet, for example,
right.
This is server SRV. This inside machine, what is source IP 200, 210, 200, 211. Because traffic is going to hit, and now source port number is, for example, 10,000. For example, for this source port number is 10,000, 10,001, 10,001, for example. Then how your firewall will identify if reply packet is coming? How firewall will verify this reply packet is for this one or for this one? Behalf of your port number. Because in between this inside machine, this server source port number is 10,000. So when the reply packet will come, Firewall will verify, okay, reply is coming from 8.8.8, okay, and this reply is for telnet, and this reply is for what? This particular source port number.
Right.
So now Firewall can identify, okay, this source port number was generated by PC number 1.
Then, like what my question was, generally when I'm configuring the rule, I just define source IP address.
Configuring rule is a different thing.
Okay.
Okay, configuring ACL rule on firewall is a different thing.
But technically it works in the same way, right? Like for example,
in rule you are using source IP, destination IP, and port number.
Yes.
Destination port number. So you can only define source IP, destination port. You cannot define source port number.
Okay. Now it's clear. So when we define the port number, basically we are defining destination port number.
Exactly, always.
Okay, got it.
Okay, so now let's verify again. So connection. So we have connection tip, exit. So it means traffic is traveling. As per our discussion, traffic is traveling from higher security level to lower security level. No problem. Right. Now, in case, if I'm trying to initiate my traffic from outside, for example, if I want to check traffic from lower security level to higher security level, then
it should not work.
It's a block, right? Let's check. Okay.
Yes, dear.
So now this is your inside router. So host name is inside. Okay. So I'm trying to enable telnet line VTY 04 password 69E123 login. So let's initiate our traffic from R3. Now host name is okay. Host name is done. So I'm trying to initiate. First, I'm trying to ping 1.1.1. So from this outside router, I'm trying to ping this inside loopback. Success rate is 0. No problem. Let's initiate the telnet connection. 1.1.1.1.1. See, Kashif, I'm not getting reply.
Yeah.
I'm not getting reply.
Still trying, yeah.
So, yes. So as per our discussion, traffic is not allowed from lower security level to higher security. Everything is denied. By default, traffic is allowed from higher security level to lower security level. I hope it's clear for you.
Yeah. So that means we are secure. Like no one from ISP or from outside, they cannot enter into inside network.
Yes. But but the point is what we need to allow. We need to allow because I need to allow some outside machine, some outside PC to access my web server, for example, to access my FTP server, to access my DNS server. So yes, we need to allow. And if you want to allow, by default it's denied, but if you want to allow, you need to configure what? ACL rule. Access control list. ACL. So we'll discuss ACL later, but right now, let's complete our routing section.
Okay.
So what we have, this is our static and default routing. Clear?
Yeah.
Let's go on to the router. So on router, you can verify your routing configuration. Show run route. The show run route, you can get all entry with route command. So yes, we have outside entry, inside entry, DMZ entry. Now, in case now I want to delete all these entry because I want to configure RIP, EIGRP, and OSPF. I want to use default routing concept here. Dynamic routing concept here. So I need to delete. So what we have as per static configuration, I need to delete all entry one by one.
Right.
You can type no command, you can
And
copy
then
this
copy
command,
paste. Yeah.
you can paste. But it's a firewall. We have good feature in firewall. In router, yes, we need to use no command. Here,
Okay.
what we can do, we can use no, or no. We can use clear configure. Clear configuration. So I want to clear all the configuration, which is start with the root command.
Okay.
So with a single line, you can erase all the configuration which is start with the root. If you press enter, clear configuration root. So now this time you can verify, show, run, route. There's no any entry. This time there's no any entry. You can verify your routing table. Done. Clear now, Kashif?
Yeah.
So this is what our static and default routing. Now we can discuss dynamic routing, but not today, tomorrow.
Right.
And see, please connect. Let me talk to our trainer. Okay, you can do your demo discussion on pen testing. Okay.
Sure.
Give me 5 minutes. I will update you.
Sure.
Bye, Kashif.
Okay.
I will upload the previous session video and today's session video.
Yeah. Okay. Thank you. Bye.
So remember our static and default routing configuration on Cisco ASA firewall. Today we can focus on dynamic routing configuration. We can discuss RIP implementation, OSPF, and EIGRP. RIP is called routing information protocol. RIP always works with hop count, least hop count, best route. OSPF is called open shortest path first. In OSPF, we have area concept. We can create multiple area, but area 0. We can create multiple area. For example, we have multiple devices, multiple nodes. So we can create area, multiple areas.
Right.
We can put all our devices into the area, but the rule is what? You have to create area 0 first. And the rest of the area, for example, area 10 and area 20 must be directly connected with the area 0. So this is the rule. So we can implement OSPF now, and then EIGRP is called Enhanced Interior Gateway Routing Protocol. This is Cisco standard protocol, EIGRP. We can only use on Cisco devices. If you remember RIP and OSPF, so these two protocols are open standard protocol. We can use on Cisco devices and on other vendors also.
Right. So what's any difference like when we use them in Cisco switches and routing versus using them on the firewall?
What RIP and OSPF?
Yes, all three.
See, you cannot use EIGRP on other vendor.
Okay.
Because it's a Cisco standard protocol, we can only use in Cisco.
Okay, but switches as well as firewall, right?
See, switches are the layer 3. Layer
3, yeah.
Actually, in switches we have two options. Either you can go with the L2 switch. On L2 switch, you cannot configure routing. And yes, on L3 switch, you can configure your routing option. On L3 switch, you can configure all RIP, OSPF, and EIGRP. No problem.
Right.
Okay. So here we have same.
But technically they are same. Like
concept is same. Story is
concept
same.
Is same.
Yes,
Okay.
Story is same.
Okay.
Only the point is how to configure.
Okay.
How to configure on other devices. So wait, I'm trying to configure basic stuff first. I'm using same topology if you remember. DMZ router, inside router, and outside. So I have a same topology. One firewall device, Ethernet 0 inside, Ethernet 1 DMZ, Ethernet 2 outside network. So let's try to configure IP address again. So interface Ethernet 0, name it inside, 200, 200, 201, mask, no shutdown, no shutdown. Let's configure Ethernet 1, name it DMZ, security level 50, IP address 10.1.23.1/24. Exit. Now Ethernet 2, name it outside, IP address 10.1.32.1 255.255.255.0/24. Now exit. Show interface IP. Done. Basic configuration. Now we can move on to the inside router. Let's configure it now. $200, 200, 210 mask 255.255.0. Let's create loopback 0 1.1.1/32 show IP interface. One physical interface and one loopback. Let's configure DMZ router. (23.10/24). Now one loopback 2.2.2/32. Now outside router.
Outside will be FA2, right? 0/2.
0/0/.
Oh, 0/0. Okay.
Okay, so basic configuration is done. Now we can focus on our routing configuration. So how to configure router RIP on R1. So let's go on to the R1. So on Cisco router, command syntax is router RIP. If you type question mark, you will get all the options. See,
Okay.
yeah, GRP, OSPF, RIP. So let's configure RIP. Version 2, network 200, 200, 200. So we can advertise our directly connected network into RIP. So 200, 200.0, then loop back 1.1.1. No auto supply. Done. Let's go on to the R2 router.
What is this auto summary line?
It's to disable auto summarization. By default, auto summarization is enabled in RIP, so we have to disable.
Okay,
this is
so
what
I don't know.
See, there is a concept. So there is a concept is summarization. Okay, summarization. Okay. So it's a routing switching concept. It's a big concept. Okay.
Okay.
But if you don't use this command, no problem. No problem.
Okay.
You can for routing configuration, you can only use router RIP and you can advertise.
Okay.
Okay, this command you can use when you don't want auto summarization for routes. So no problem.
Okay.
If you don't want to use, no problem. Okay.
Okay.
But this concept, this no auto summary command, we are using to disable auto summarization.
Okay.
Okay. What is summarization, Kashif? If you want to know, so I can share the video. Okay, you can check on our my
Sure.
YouTube channel. There is a video on summarization, route summarization.
Sure.
Let's move on to the DMZ routers. So routers version 2 network 10.1.23.0 2.2.2 no auto summary R3 router rep version 2 10.1.32. network and 3.0.3 no auto summary.
Right. So just to recap, like what these two lines are telling, like 10.1.32.0 and 3.3.3.3.
See, in what you can do in dynamic routing protocol, you can advertise your networks only. If you remember, in dynamic routing protocol like
Correct.
or in OSPF or in AIGRP, you can advertise your directly connected network. So, for example, we are here on R3. So, see, if you remember static routing, in static routing, if you are on here, for example, on R3,
correct.
In static routing, you need to create destination entry and then gateway address.
Exactly.
Then again destination entry and then gateway address. So you need to create all the entry manually. Correct. And you need to know what is destination IP address. You need to know what is destination IP address. But in dynamic, the good thing is what? In dynamic routing protocol, the good thing is what? No need to know what is destination IP, what is destination network. Only what you can do, you can advertise your network into protocol.
Okay. So we are in advertised position.
Yes.
For anyone, right?
See, we can only advertise our network into the protocol. The protocol will communicate with each other. See, we are using RIP on all the devices. Right. We can communicate with each other. They can send a hello packet information with each other, and then they can create a relationship. Whatever relationship you can see, or they can establish the they can exchange the routing protocol. They can not routing protocol. They can exchange the route information with each other.
Right. Got it.
So here we are using RIP right now on all the routers on R1, on DMZ, and on R3.
Correct. And they are in advertised position at the moment.
Yes. See, you can, for example, on DMZ router, I'm trying to advertise my 10.1.23 network and 2.2. So these two networks are available onto this loopback and this 10.1.23 network. Now we can go on to the firewall device, and on firewall device you can see we have three connected networks: 200 network, 10.1.23 network, and 10.1.32 network. So let's advertise these network into RIP protocol. Okay, before advertise, you can verify your routing table information. So you have only your directly connected network information. See, 200 network, 10.1.23 network, and 10.1.32. So you have only your directly connected network information. Now let's advertise on firewall. Same command syntax, not different. Router, RIP. Simple. Version 2. Version 2. Now network 200.0 done. Network 10.1.23.0 done. 10.1.32.0 done. No auto sum. Done.
These three lines are not clear. If you can just explain.
You can advertise your networks. I'm trying to advertise. See, if you remember.
Oh, all three, right?
Yes. Because on firewall, I have three networks.
Right.
200 network, 10.1.1c network, and 10.1.32 network.
Okay.
So I have three networks. That's why I need to advertise all my networks into RIP.
Okay. So one question here, when we were working on the routers, we were entering like 1.1.1.1, 2.2.2.2, and 3.3.3.3. So why we are not entering here? Why we are entering there? Like,
see, on R1, you're talking about
yes,
R1. For example,
yes,
see, on R1, what I have only two networks.
correct.
I have on R1, you can see I have 200 network and one loopback.
Okay.
So I need to advertise my 200 network and one loopback in RIP protocol.
Okay. So if I have like 10 computers connected on that router.
Not computers.
Okay.
It's a
Okay.
network. It's a network.
Oh, okay.
Into this network, what you have?
Okay. So you mean
maximum computer what you have into this network? This 200.200.200.0. So this is
okay.
class C IP.
Okay, got it.
In
Got
class
it.
C, maximum computer you can attach 250.
Okay, got it.
So
So just in case if I have another network connected on the same
yes,
R1
exactly,
router, I
yes.
will enter one more line of that
Exactly.
network.
See, for example,
Okay.
one more network, network. So I need, for example, this is 20.20.20.0/24. This is 10.10.10.0/. So you need to advertise these two networks into
Okay.
RIP.
Okay, got it. Now it's clear.
Okay, now you can verify your routing table information on Firewall. Kashif,
Yes.
see, try to revise your CCNA. Okay, this can help you. Otherwise, do one thing. No need to go for training. Okay, no need to spend money for training. You can purchase only the videos, live session videos. You can purchase CCNA because CCNA is very important. Kashif.
Right.
CCNA is very important. This can help you a lot.
Right.
So no need to go for the live session because this will no need to spend too much money. What you can do, you can just purchase the videos.
Right.
And whenever you have time, try to watch one video every day.
Right.
One video. For example, let me show you because season is very important. Let me show you. For example, I'm sharing some video, okay, as a demo, okay,
right.
Related with season. You will get automatically. Let me show you. I can share, okay. I can share after session.
Sure.
Okay, some videos you can watch this. Then you will get a clear picture. The point is what season is very important. Okay, to learn any firewall or any other because you will get a clear idea about the packet flow. How the packet is traveling. Okay? Deep packet.
Yeah.
Okay,
because I did the course, but normally like in day-to-day operations.
Just try to watch. See,
yeah.
You can watch only one video per day.
Okay. Sure.
Okay, now so
if I can get that idea, like, okay, this is the topic I should revise like one day before. So what will happen? I can revise them before I join tomorrow.
Yes, and see, try to purchase a live session video. Okay.
Right.
So you have a batch videos, so this can help you.
Right.
Okay, so let's verify our routing table with show route command. So you can see we are receiving some routes information with R. R is called what? R is called RIP. So we are receiving routes information with RIP. See, 1.1.1, 2.2.2, 3.3.3. And this is what? Any idea?
120, I don't know, it is a hit or what?
It's an AD value. Now, what is AD value? That's why I'm telling you. Okay?
Right.
Very important. Yes, very important. Because see, it's a common topics. It's a common topic for any firewall device. Routing implementation, NAT implementation, VPN implementation. These are the common topics.
Right.
Okay, so AD is called administrative distance. So I'm not going in deep, but
okay, got it.
RIP AD value is 120.
Right.
It's called administrative distance. But you can see we are receiving route information. So from firewall, if I'm trying to ping 1.1.1, I'm getting reply. Ping 2.2.2. What is ping full form?
Ping full form, no idea.
Packet internet grouper.
Okay.
Okay. Now, so you can ping. So we are getting reply. Now let's initiate some traffic. See, so I'm on to this inside router, Kashif. Okay, inside router. So let's initiate some traffic. Remember our previous session, yesterday's session?
Right. Yeah.
Okay, traffic is by default allowed from higher security level to lower security level. No need to configure any policy. Okay, so in case, let's verify routing table here, show IP route on router. So yes, we are receiving two routes information from DMZ router, routes information from outside router. Yes, I'm receiving. So in case, if I have a route, so I can ping. So let's try to ping. I have a route, so I can ping. So I'm trying to ping, but I'm not getting reply. Kashif, can you help me? Why?
From 3725.
I'm trying to ping from this inside machine.
Yeah, because it's ICMP, it's not TCP or UDP.
Perfect. Thank you. Yes. So what? This is ICMP traffic. By default, traffic is allowed, but only TCP and UDP traffic.
UDP, yeah.
So let's configure telnet here. So we can try. So line VTY 0 space 4 password Cisco 23 and now. So this is for telnet command. Telnet is enabled, so we can initiate our connection. Telnet 3.3.3. See, Cisco 123. Cisco 123. So this is what outside. So we can access. And if traffic is traveling through the firewall box, then firewall will maintain the state of connection in a connection table, in a state table. And what is the command to verify our connection table or in state table? Show connection, right?
Right.
What we have 200, 210 source port number, destination IP, destination port number, and TCP.
Correct.
Traffic is traveling from inside to outside.
Okay. So this line will generally only appear once once the session is active, right? Exactly. As soon as we disconnect telnet, this will go away.
Yes.
Okay.
For example, if you exit this network, so you can see here, show connection.
Okay, got it.
So when traffic is traveling, it will maintain the state of connection.
Okay.
So this is what our RIP implementation. Now let's try to delete RIP because I want to implement EIGRP. So no router RIP command to disable RIP. Let's go on to all devices. R2 command is no router RIP. Outside router, no router RIP. No router RIP. Oh, sorry, global configuration. No router RIP. Let's go on to the firewall device now. So on firewall, you can see show run router. So yes, we have RIP configuration.
Yeah.
We have RIP configuration. So you can use clear configure router. I want to clear all the configuration command which is start with the router command. So we can erase. So now you can verify show run router. We don't have any entry, and if you verify your show routing table, show route command to verify your routing table. So right now I have only a directly connected network information.
Right.
Let's implement EIGRP. So it's a simple task. Let's start with the R1 first. So EIGRP, router, EIGRP, and autonomous system number.
Right.
Now network, and see, if you want to revise your protocol,
EIGRP, yeah.
EIGRP, so we have a, okay, I will share some video, okay, on router.
Sure.
So network is called 200.200.0, then mask, wildcard mask, then network 1.1.1 wildcard mask, no auto.
Okay.
Let's go on to the DMZ router. So show router EIGRP autonomous system number, and we have two network 10.1.23.0 wildcard mask, and 2.2.2 wildcard mask. No auto sum. Now we can move on our outside router. So router EIGRP 10 network 10.1.32.0 wildcard mask area. So not area. Network 3.3.3 wildcard mask done.
Okay. So for EIGRP, we have to use the same number, right? On all routers. Only then it will work.
Exactly. Yes.
Okay.
This is called autonomous system number.
Okay.
Value is varying between 1 to 65,535.
Okay, and should match on all the routers, right?
Into this topology.
Right.
If for example, into this topology, if I'm using autonomous system number 10 on router 1, so same number I need to configure on other devices.
Okay, got it.
Now we can go on to the firewall device. It's a very simple, same like router EIGRP network 200.0 mask, because Cisco ASA firewall don't know anything about wildcards. This is what wildcard mask.
Right.
A wildcard. So, but in Cisco ASA firewall, if you want to advertise your network, okay, you can advertise with your mask. Okay. Cisco ASA firewall box don't know anything about wildcard.
Wildcard. Okay.
So now network 10.1.23.0 mask. Now network.
So this rule is common for all type of Cisco firewalls, right?
Yes.
They don't know wildcard mask.
Yes.
Okay.
Any Cisco ASA firewall.
Okay.
Now mask 255.255.255. Done. No auto summary. Now see, we have neighbor relationship information. You can verify on firewall, show EIGRP neighbor. So yes, we have 3 neighbors: outside router, DMZ router, and inside router. See, and if you verify your routing table, show route. So yes, we are receiving route information from R1, R2. We can also receive, we are receiving from R3. Clear?
Right.
Only the problem you will face, what is the concept exactly? Okay. The configuration task is very simple. Now, let's disable EIGRP. No router EIGRP 10. Let's go on all devices. So on R2, no router EIGRP 10, and on R3, outside router. No router EIGRP 10. Let's go on to the one, and no router EIGRP 10. On firewalls, we can use save, clear configure router. Done. Now you can verify this time. Same routing table. If you want to verify, it's show route command. Show route. See, so we have only directly connected network.
Correct.
Okay, now we can implement our last dynamic routing protocol is called OSPF. So you can create multiple area, for example, in between firewall and router 1, I have area 0, sorry, area 10, for example. In between firewall and DMZ router, for example, area 0. In between firewall and R3 router, area 30, for example. So you can create multiple areas. But the point is what? How to advertise our network into area on Cisco ASA file. So I'm not creating multiple area. Let's go with a single area. Okay, I want to advertise all my networks into area 0. Why area 0? Because area 0 is called backbone area in OSPF. You have to create area 0 first.
Right.
So let's go on to the R1 first. So as per my scenario, I'm trying to advertise all my devices into area 0. So let's go on to the R1 router OSPF process ID network 200 or 200.0, then wildcard mask, and I want to advertise this network into area 0. So you can see we can create, we have a big number. Okay? You can create multiple areas.
Right.
So I want to advertise in area 0, area 0. Now
so I want to advertise this network into area 0. That's what this line means. Okay.
Yes. Now 1.1.1.1 wildcard mask area. Now let's go on to the R2. So on R2 we have two names. So let's advertise router OSPF process ID network 10.1.3 network wildcard mask area 0. We have a loopback here 2.2.2 wildcard mask area 0. Let's go on to the outside router. So router OSPF process ID 10.1.32.0 wildcard mask area 0. Now 3.3.3 wildcard mask area 0. Let's go on to the firewall. Same simple task. What you can do? You can use a command router OSPF process ID 200.200.0 mask and area 0.
Okay.
Now network 10.1.23.0 mask area 0. Now network 10.1.32.0 mask area 0. Done.
Okay.
Now you can verify with show OSPF neighbor. Show OSPF neighbor. Yes.
Oh, okay. It's clear. Yeah. I thought it's entered 2 times. So one is 23, one is 32. Yeah.
Yes.
It's okay.
Now the show OSPF neighbor command, you can get your directly connected networks, directly connected neighbor information.
Correct.
So
on this ASA.
Yes, on ASA. So we have 3 neighbors: 1.1.1, 2.2.2, 3.3.3. And see, in OSPF there is a concept of DR. Do you know about DR?
No.
You need to revise. That's why. Okay, DR. It's called designated router. Okay, in OSPF we have full state. We have 7-stage process.
Right.
If 2 routers are exchanging packet in between, two routers are exchanging packet, OSPF packet, you will see. So there are 7 stages. OSPF 7 stages: 1, 2, 3, 4, 5, 6, and 7. 7 stages called what? Full. It means complete. Neighbor relationship is established. Okay. So we have 7 stages. Okay. It's called Xstart, exchange, loading, multiple pages we have. So these options you can learn in CCN.
Right.
Okay. Now, so we have routes. So it's not routes, it's a neighbor information. So we can verify our routes. Show route So yes, 1.1.1, 2.2.2, and 3.3.3. Clear, Kashif?
Right. One,
Now,
right.
Kashif,
1,
clear,
2,
please.
3. Okay. Yeah.
Okay. Now, Kashif, please clear me one thing. You know about ACL?
Yes.
Access control list, right?
Yes.
Okay. In ACL, we have two options, right?
Correct. Standard and extended.
Thank you. Standard and extended.
Right.
Okay. So what is the difference in between standard and extended?
Yeah, extended like goes up to protocol level, like we define the TCP and port number.
In
but the
extended.
standard just in extended. And standard just works on the IP level, like
network,
it not
IP address.
Network. Yeah.
We can block any specific IP or
correct.
It means this standard ACL we can use for only source. We require only source IP address.
True.
In standard ACL. In extended ACL configuration, we need source, destination, service, and protocol.
So
we require these options to configure extended access list.
Right.
And for a standard ACL, we require only source IP or source network or source subnet.
Correct.
Okay, so this is the concept from CCNA classes. ACL is for what? Access control list.
Right.
Okay, and we have two type of ACL. It's called numbered ACL. Numbered ACL and named ACL.
Right.
Named ACL. So in numbered ACL, yes, you can configure standard and extended. And in named ACL, same, you can configure numbered and named. It's a CCNA topic.
Right.
But now in Cisco ASA firewall, you cannot use numbered ACL.
Okay.
In Cisco ASA firewall, you cannot use numbered ACL and you cannot use standard ACL. No concept.
Right.
In Cisco ASA firewall, you can only configure named ACL, and in named ACL, you can configure only extended access list.
Right.
Okay. So this is the concept exactly. Right. See, so we have root side now. So I hope it's clear how to configure routing protocols on Cisco ASA firewall.
Yeah.
So wait, let me delete these configuration. Clear configure router. Let's go on to this outside router. No router was 5. No router was 5. Let's go on R1. So no router was PO. So I want to create a small topology for ASIL configuration. Okay. See, here we have a small topology inside network, outside network, and DMJ. So for basic connectivity, I'm not using any dynamic routing protocol. Let's establish basic connectivity. For basic connectivity, we can use static or default routing, no problem. So from all routers, you can say from R1 DMZ router and outside. So from these routers towards firewall, I'm configuring default route. Okay, wait. For basic connectivity, I'm using routing concept, but static and default only. So default route, any network, any mask, gateway from R1 to towards firewall. Let's go on to the DMZ router. So IP route, any network, any mask, 10.1.3. Outside router. So IP route, any network, any mask, and 10.1.32. And let's go on to the firewall. So on firewall, I'm trying to configure static routing for inside and outside and default routing for outside name. Okay, this is our task.
Right.
So route command, route 1.1 route inside network. So not route inside network 1.1.1. This is the mask. Now 200.10. Now route DMZ route DMZ 2.2.2 mask 10.1.23.1 23.10. It's a router IP address. Now route DMZ outside any network, any mask, and 10.1.32. So for basic connectivity, I have basic connectivity. Let me show you.
Right.
Show route. So I have some route information in my routing table, static routing configuration, and what default routing configuration.
Right.
Now you can go on to this router. Yes, we have a default route towards firewall. So in case if I'm trying to initiate, if I'm trying to access telnet, for example 3.0, I have a route. I have a default route, so I can access.
Correct.
I can access. See, I can access. So traffic is traveling from higher security level to lower security level.
Lower security.
By default, it is allowed. By default, it is allowed.
Right. Right.
But in case, if I want to allow traffic from lower to higher, for example, if I want to, for example, this exit interface IP address is 10.1.32.10. Here we are using.
Right.
So from this exit interface IP address, I want to access 200.200.210. This is here. I'm using 10. So let's try to generate packet first. So from this outside router, ping it. Not ping. Let's access telnet. So I'm trying to enable telnet first.
On router one.
Telnet on router. So line VTY 0 password CCIE123 login. Now let's go on to this outside router telnet 200. So I'm trying to initiate my traffic from this exit interface. I'm trying to access 200 and I can't access because by default traffic is denied from lower security level to higher security level. Right. That is the problem. So in that case, if I want to allow traffic from lower to higher, so we need to configure ACL on firewall.
Right.
So the concept is what? Topic is what? We can configure ACL concept on firewall. So how to configure? Let's go with the syntax. So command is access list. Access list. I told you.
So it's different than switches, right? Normally we start IP space access.
Yes, list. on router, on switches, you can use a command IP access list.
Right.
But on firewall, command syntax start is access list directly.
Okay.
Like on router, on Cisco router, you can use show IP route command.
IP, right.
IP route command to verify your routing table. But on firewall, you can only use show route.
Correct.
So here command start with the access list. Now, I told you, you can only configure named access list. If you type question mark here, is asking for a name.
Right.
So for example, if I'm using outside, it's just a name. Outside, it's just right. Now question mark. Okay. Now you need to define your permission, deny or permit. So right now I want to permit, allow. So permit. Okay. Question mark. Now you have to define your TCP UDP traffic. This traffic is what? TCP. right?
TCP.
TCP channel. Question mark. Now it's asking for source IP. What is source IP address? As per our topology, this 200, 200, 210 is trying to access, sorry, this 10.1.23.10 is trying to access 200, 210. So as per our task, our source is
10.1.30.
Our source is a specific host, specific IP address. That's why I'm using host. Host means what? Use this keyword to configure
computer.
Source host computer. Yes, you can see. So host is what? 10.1.32.10. So this is the source, and this source can access host what? Destination IP. So this source can access 200.10. Now I want to allow service. So this
23.
This outside PC can access telnet service. Okay.
Right.
So equal to port number 23.
Right.
Telnet port number is 23. You can press enter. Done.
Right.
Now you can verify show run access list. You can verify your ACL route. This is your ACL route. Any problem?
Correct. No, all good.
Now, if you remember your ACL configuration on Cisco router, whenever you configure your ACL, you have to apply on interfaces, right? On Cisco routers, you have to apply this ACL on interfaces.
Yes. On routers, yes, correct.
Yes.
We have to apply on interface.
So same we have. If you have an ACL and if you have an ACL, so you have to apply on interfaces. How to apply? Command on Cisco ASA access group. Now it's asking.
But same thing. Like
exactly.
We don't use IP. We just use the word access group.
Exactly. Yes.
Okay.
And no need to go in any interface.
Number.
Cisco router, if you remember, you have to go into the interface. Then you can use a command IP access group.
Right.
Here we are in global configuration mode. We can directly use access group.
Right.
Now question mark. Asking for name. Asking for name. So what is ACL name?
Outside.
Now in interface, and on which interface you want to apply this ACL route? This outside. So traffic is coming from
here,
right?
From outside.
Coming from outside, and it's going to hit onto this Ethernet 2.
Yes.
So this Ethernet 2 interface is what? Outside interface. So interface is what?
Okay.
Outside. So I want to apply this outside ACL name on outside interface. Clear?
Yeah. So just one question here. The first outside.
It's a ACL name. Remember?
It's a name. It's a name, right?
It's a name.
Okay. No, what my question is that this name should be same, or we can change.
No, you can use your name, my name, no problem.
No, here, like on the ACL, I'm using outside, but while using this command,
you are talking about this option. This option.
Yeah. Can this name?
I'm telling you, you can use your name, my name, no problem. It's just a name.
Okay. No, what my question was, access-list space outside, and on the access group, can I use different name? Like, can both names be different? No, they should be same. Okay.
Now you can apply, and once you apply, so this time, in case if I'm trying to initiate my traffic, if I'm trying to initiate, let's initiate again. Okay. This time I can see I'm on outside router. Okay. Previously, host not responding. This time we are getting a page. And what is password on router? Wait. CCI.
Yeah.
Password is what? Yes, CCI. Yes.
Yeah. So one question here. I know the answer, but just to understand it more better. So why we are applying this on Ethernet 2 of ASA firewall, not on Ethernet 0?
Because traffic is coming from outside.
From outside.
And it will hit onto this interface.
First, okay.
Yes.
So if I put this on Ethernet 0, it will not work technically,
no,
right?
Exactly. Yes.
Okay.
Yes. So now, see, password is, I think CCIE 123. Let me check again password. CCIE 123. CCIE 123. Tell me. CCIE 123. Yes, I can access. Clear?
Yeah.
Yes, Kashif.
So yes, so one question here, like, can we extend this lab little bit? So what I mean by little bit, like if we can connect one computer on the outside.
It's a computer. It's a computer. See.
Okay.
Think about PC. Okay. You can use router. Okay. You need an IP address only. Kashif.
Yeah. Yeah.
You need an IP address. So it is on router or it is on PC or it is on any devices. You need just an IP address. So right now, let's think about it. It's a PC. No problem.
Yeah. No,
And
what my question was.
interface IP address.
Yeah. So what my question was, on router 1, there is another network after router 1 and the PC is connected there. Like for example, maybe 100.100.100.0. So what my question was, like connecting two separate PCs after 3725 on a different network. So in that case, how we can cross router and firewall?
See, you have to see. Point is what here we are. This is the nearest one, right? This is the nearest one device. So you can filter all your traffic here. So filtered traffic will go onto this route. Filtered traffic.
Okay.
So what you want to, for example, on your LAN side, you have one more network, right? This is what your
yes, and the computer is there, yeah.
Computer to it. So for example, with your router, here is a switch.
And here is some other network.
Computers, multiple.
Correct.
This
on
is
100.